Okay, so this is going to represent our notes for what we're going to call 6.3. And this is when we're going to start to talk about the similar triangle postulates. So we've been through now a review of ratios, which compares one part to another, sort of in a fraction if you want. And then we talked about proportions, which talks about how does that fraction compare one to another, right? And we're talking about similar shapes. I think we already said, right, that the sides are proportional, which means the scale factor or the ratio, however you want to look at it, is the same. Now, what we're going to go through now are the postulates that get us there a little bit quicker, if you want, okay? Because what we know now is all the angles are the same and all the sides are proportional. This is all leading us to do some proofs for the last section. So, let's go over the first one here. The first one, all right, is called AA. Now, you might be like, where's the third A? All right, well, we don't need the third A in a triangle, right? Because the triangle sum theorem, by extension, says if I have one angle match corresponding, I have another angle match corresponding. If we do kind of an idea where we subtract 180 from both of those things, we get the same thing. So we're actually going to emphasize the fact that if you write AAA, we're going to take some credit from that because that's showing a lack of understanding that AA is enough. So let's look at number one here. All right, so hopefully we can look at this one and go by setup. Everybody agree we can claim this one right here by vertical angles. So that's one of them. And then here, if you see this, these are parallel sides again. Remember, parallel sides don't say anything about sides. They say something about angles. So what could I claim here? And again, one of the things that I saw some students work out is if you extend these lines, I'm looking for a transversal that works, okay, where both of the angles are inside. I don't know if you can see it or not, but that's going to be, this line here is going to allow me to produce two angles here and here. Okay, and those are alternate interior angles, if you remember. And that's enough. Once I get AA, what we can say is this is similar. Okay, now what do I get by saying it's similar? I know the third angle is the same. What else do I know? I know that all the sides are proportional without checking them. Okay, so that's the power of doing these postulates. All right, now, if we do it then again, if we check it, we've got to match the letters up, right? So D, C, E, if I choose that, remember similar is a single squiggle, is going to be congruent to F, G, E. Okay, so that's one example. Let's look at number two. Number two here, right, and this is a common one where we have two triangles nested inside of each other. Now, for this one, what can I claim? I can claim angle L is an angle in both, because what you're looking at here is you're looking at a little triangle, and then you're looking at a big triangle, okay, here. Now, if we break both of those out, what I would have is I would have a little triangle here, if you want, and then I would have a big triangle here. I'm not sure if that picture makes good sense, but that's what I would have, where these are both L, okay, so that one's the same. Now again, this one utilizes the fact that they gave you parallel lines. So here, parallel lines, what can I claim? You can claim a couple different things, right, but I'm just going to claim this one and this one, and that's enough, right? You could also claim this one and this one if you want. But again, once I get there, AA is enough, so yes, by AA. And what do I have then? We do want you to practice that if I pick QLP, what is similar there, right, by location? I'm going to do M, notice L's the same, N. Okay, so you can track those letters. All right, let's look at number three. Number three, just a simple one again. If I have a right triangle, pretty much done. Yep, there are the two. Here's an angle that's the same. Now, this one, they're asking you then, triangle sum theorem. What I have to do is find the other angle to determine what goes on here. If you take 180 minus 90 minus 39, I do get 51. And here I would get 39. Again, is that similar? Yes, by AA, even though it's all three A's. All right, and then again, just to practice, that would be DCE is similar to triangle FGE, if you follow that. Okay. All right, now let me just look here at number 4 real quick before we move on. Okay, oh wait, that's not right. These are the wrong letters. So number 3, if I do it, it's going to be SYE, sorry, and WCH, of course. Yeah, not the DE. I was doing, yeah, I don't know what I was doing. All right, so let's look at number 4 here, okay, for this section. If I go check the third one here, Okay, so I have a 68 that matches. All right, but just as a math exercise, if I check the last one, this is 58 if I do triangle sum theorem, and this is 49. Now what does that tell you? Okay, I have one angle is the same, but I don't have another angle is the same, so guess what? That means no. Now by saying no, just a reminder, that means that the angles don't match, and it also means the sides are not proportional. Okay, and again, we're not going to go by looks. We have to go by sight. All right, let's go on to the next one here. Next one is side, side, side. If I can prove that three sides are proportional, all right, then what do I know automatically? I know that all the angles match. Okay, that's the power of doing this. So this is one where it's a similar postulate. It's also a congruent postulate. So it's a congruent postulate if the sides are exactly the same. It's a similar postulate if the proportions are the same. So what we do here again, when you look at it, just so you can organize it, the only way this has a chance of working out is you have to put the biggest side with the biggest side and the smallest side with the smallest side, and then of course the middle and the middle. That's how I'm going to train you to do it. And I'd also like you to put the bigger number on top. So for the first ratio here, I'm going to say 31.5 over 20.25. Okay, then I'm going to go to the smallest one. Okay, the smallest one on the one triangle is 14. Smallest here is 9. And then I'm going to go get the middle one. Okay, so the middle one on the big side is 21. The middle down here is 13.5. Now, if you go through and you check all of these, okay, what you're going to do is divide and see if you get the same thing. So if you do it, you're going to get something, you're going to get 1.5 repeating for all of them. Okay, and you have to check all of them. So check, check, check. That means this is yes by side, side, side. Again, if I can do my letters right this time, you get K, N, R. If I pick that one, again, similar symbol, D, E, S. Okay, so that one works out. Let's look at number 8 here. Number 8's a little tricky. Do you see the two triangles? So this is one thing we need you to do. Here's a little triangle here. And in the big triangle, it's nested inside the big triangle. So the big triangle's here. So we got to think about those sides, all right? Do you see that this length over here is 21? This length here is 28 by adding them together. That's what I'm going to use. So again, I would go from big to small. So if you look at it, which one's the biggest side? On the big one, it's 42. Biggest side on the other one is 30. So I'm going to look at that ratio. Then what's the smallest one? The smallest one on the big one is going to be 21. The smallest one on the other one is going to be 15. Okay, and then what's the middle one, right? So the middle one is going to be 28 to 20. Now again, what you want to do on your calculator is check all of these. Okay, if you check the ratios, you're going to get 1.4 for all of them. Check, check, check if you check them. Okay, what that means is yes. And again, if I'm doing the triangle, triangle UWY is similar to triangle VWX. Okay, that's how you would do it. All right, number 10, let me just touch on that real quick. Number 10, to try to figure out which is which, again, this angle is the same. That might be a little bit of a hint. But when they give you these, right, because it's hard maybe to manipulate that in your brain, the best way to do it, again, for number 10 is for you to go big to big, little to little, middle to middle, so that you don't get them crossed up. Okay? All right, so again, I don't want to have this video go too long, so let me hop to the next one. Here's your prep. All right, the last one here is SAS. You might recognize SAS. SAS is a similar postulate. It's also a congruent postulate. It's a congruent postulate if the two sides have congruent measurements. Okay? It's a similar postulate if they are proportional. All right, now remember, side angle side means the angle is included, right? It has to be in the middle. So let's look at 13. Everybody see I have the angle in the middle, and I have two sides on each side. That is side angle side, so that sets up as a possibility. What do you have to check? I have to check the sides. Now again, the idea of this would be I would take the biggest on one side and compare it to the biggest on the other side. That's the only way I can possibly get a match, and that's just one way to do it. So here's the one triangle up here, of course, right? I'm sorry. Okay, so here's the big triangle up here. I'm not sure, there we go. And the little triangle. So on the big triangle, the big side's 24. The little side is, the biggest side is 12 on the smallest one. And then the other one, oh, that's a lie. The biggest side is 48 over 12. And then the other one is 24 over 6. This one's kind of nicer maybe. I don't know if you can see it or not, but I get 4 for that. 4 for that. The angle matches. That's enough to say then for this one that triangle, if I use the right letters again, SER is congruent to triangle GEF. And again, I'm matching those up as I go. All right, for that. So if we have that, that's enough. And what does that tell me? By proving a side, the included angle and a side, what else do I know? I know the other two angles are the congruent, and I know the last side is proportional with a factor of 4. Okay, so that's kind of how that one works. Now let me look at number 14 here. Trying to pick out the ones that have some issues. Number 14. Now this time I have two sides, and I do have this angle. Now I don't know if you can see it or not. Okay, this is not good enough because this is not side angle side, right? This is our famous angle side side, right? Which is not a thing. Okay, for two reasons. One, it's a bad word, and two, it doesn't lock it in. If you remember, there's a hinge that can be involved, which creates two different triangles. So this is a no. So just a reminder that two sides in any angle aren't the same. It has to be two sides and the included angle. Okay? All right, so that is your prep here for similar. All right, what we'll do tomorrow is we'll go through some of these with you. The are we similar to open? Okay, and then we'll turn you on to your homework. All right, so again, keep track of the notes. I appreciate it.